Now we're gonna have some really hard questions. You won't be able to answer all the questions, Matt.
Maybe not. All right. So I'm just going to start screen sharing now. So let's jump in. We'll just start at the slides. So welcome everybody to Deploying Contracts Part 2. Last week we went over predominantly the information about the Harmony network itself, the different sort of network configurations that you would need to set up, dealing with sort of like various support files, like setting your environment variables correctly, and then passing that into the truffle config file, and then watching those deployments go out to the various networks, so local, testnet, mainnet. Today, we're going to take a bit of a different approach, and we're going to focus on the contracts themselves, how we would test a smart contract, like test a new function that we were building and make sure that it does what it says it does. And also we're going to look at how we actually speak like to those contracts from our applications using the Harmony JavaScript SDK. So that's briefly what today is about. So let's just jump in. So we'll put up a live recording later and we'll link everyone to the slides. So writing contracts. So we mentioned last week that Harmony uses the Ethereum virtual machine. So it's the same smart contracts and the same languages that you would normally be deploying on Ethereum. And the reason being is because it's a pretty good virtual machine. It's very compact. It's got all these sort of necessary features that we would need in smart contracts. And it doesn't make sense to just sort of kind of convolute things by creating a whole new language, a whole new programming language for writing contracts, which just seems like that's what everyone's doing right now. And it just is making it's making the whole blockchain space a little bit chaotic. So basically we run the Ethereum virtual machine, but we run it on top of Harmony, which is a sharded proof of stake blockchain. So it's a lot faster. So the languages that we have to, that we can write our contracts in are Solidity, which is the most accessible language. And this is because it has a deep background in Java and JavaScript style syntax. So it borrows a lot. It borrows a lot of the sort of class-based inheritance structures from from Java. And then it also is sort of familiar to people who come from the JavaScript world. So most contracts out there that are running on Ethereum are written in Solidity. And so that gives you a good base of sort of questions and answers on Stack Overflow. It gives you a lot of background. A lot of people can learn by examples. So that's why I'm personally just going to do today's lesson in Solidity and just recommend that. And I'm going to kind of ignore these other languages. But I would do you a disservice if I didn't tell you that there were other languages that compile in order to be run on the Ethereum virtual machine. The second most popular language is Viper because it's a Python-like language, but there are other languages. One thing that's nice about Solidity is that Open Zeppelin, a group of individuals, have a very large repository of pre-audited contracts. So these are things for like tokens and ownership and doing all sorts of crowd sales and distributions of things, and it's quite a good resource. So there's sort of like a bit of a best practices kind of repository. So check them out if you're new to writing contracts, and here's a link to the Solidity docs as well, which are they're not like normal documentation. It's very example driven, so it's quite accessible. So let's jump in to testing contracts. So when you when you kind of go to approach testing contracts, you can of course set up any sort of testing framework you want, but my recommendation here is that you kind of stick to the most popular tools, because they've done a lot of the work for you, and that would be using Truffle, which is it's simply like it's basically a test runner for smart contracts. It's a deployment framework. It will compile your contracts for you. There's a lot of really great command line sort of tools, that just a few, like 3 or 4 commands that you need to know to be very efficient in writing and deploying contracts if you use Truffle. So we're just kind of we're not going to go down in deep and sort of talk about compiling your own smart contracts and setting up your own test runner and stuff. We're just going to use kind of what comes in the package here. So here I've kind of described how you would set up like an empty Truffle project. When you first set this up and you run Truffle test, which would compile and test your smart contracts, you're going to notice that you just have this thing that says 0 passing. And that's because you haven't written any tests yet. So over on the sort of second part of setting up your test would be that under the test folder of this newly initiated Truffle project, you're going to want to set up a test that sort of speaks to your smart contract. So this is assuming that you already kind of have a contract that you want to test. Basically, this is sort of like a boilerplate for pulling in the smart contract. I've left the name HRC 721. If you guys couldn't tell, I like NFTs. I'm going to show you how this code runs in my environment. So this is just sort of boilerplate test code that I use when I'm starting to write tests for my smart contract. So you would fill this in. You would put your contract name .test.js. And then you would go back and you would run Truffle test, and it would try to run this first piece here, like it should be deployed. So let me go ahead and show you guys what that looks like. So here is my HRC 721 auction test. If you guys are tuning in from last week, you know that I'm working on an NFT auction dApp. So this is an example of what I had to do to test the contracts before I started building my dApp. And I recommend that everyone test, like just basically write your smart contract and write your tests before you even move to the dApp side of things, because it's important that you get all the functionality of your smart contract correct in your local development environment, and that it's tested and sort of proven to do what you expect it to do. And the reason is because when you move to your dApp, you're going to hook everything up. And if you have to go back and change your smart contract, it's really just a painful process. Like you're going to go back, change your contract, and you might have to change everything about your contract because you missed some feature. So it's better to just go contract test, and then move to actually designing your whole dApp and UI around everything. So let me go ahead and I'm just gonna wipe out all of this code right here, and I'm just gonna show you guys something similar to what I've showed you here, which is that I'm just gonna check that the contract artifact has this deployed method and that the instance is actually there. Oh, sorry, this should be assert OK contract instance. Little copy paste there, sorry. But you'll see here that I'm checking that I actually have 2 contracts being deployed. So I'm checking that this instance and this instance are actually real variables and not undefined. So you'll see what that looks like in just a sec. I'm going to bring up my console, and all I'm going to do is I'm going to get out of this boilerplate project that I had here, and I'm going to go into this NFT validators, and I'm just going to run Truffle test. And I only have one test here now saying it should be deployed, and that again, that's for both of my contracts. So don't worry about all that jazz. Oh, I didn't save the file. Oops. All the URLs that it's spitting out, those are just the NFTs that I'm creating in my deployment script. So just hang on. I just want to show you guys that one test is passing. Okay. So again, there's not too much complication to like complicated stuff in these tests. You can see these are grayed out. I'm not even using these variables. Really, all you need to do is grab your contract from the artifacts require. This is also a helper method. So again, there's going to be there's going to be a lot of helper methods in the processes that I'm showing you today, and you may want to kind of understand what these do. Some of them you can kind of just assume that they're always going to do what they do. So basically, say here you're going to say you want to grab your contract by name. So you can see under my contracts folder, this is the actual name of this contract here. And then here's HRC 721. I'll close that. It's here. So I'm pulling these in, and these are called the Truffle artifacts. So Truffle compiled my contracts, and it built these artifact files. I'll show you what they look like. These are just again these are like helper files. Here's the HRC 721 artifact. So it's just a big JSON file that has a whole bunch of information and the actual contract bytecode itself. That is going to get pulled into our test. Let me just close that. That's going to get pulled into our test, both the 721 contract, so for the actual NFTs, and the auction contract, the one that runs the actual auction of the NFTs. Those big JSON objects are going to get pulled in. And when we call deployed, we're looking for a currently deployed instance of that contract on a sample blockchain, and that sample blockchain is basically Truffle until we deploy it to our local network or testnet or mainnet. But basically, it's just going to give us back the current live version of that contract so that we can run our tests against it. So it sort of seems complicated, and there is a lot of extra stuff that's being kind of abstracted away and hidden for you, but it's really just to get you up and running and writing your contracts faster. So I'm going to uncomment the rest of my tests, and I'm going to run all the tests now. And you'll see, you guys can go check out this repo too. I have a link to the actual repository where I'm building this. So this is sort of like a work in progress, but it can show you that that things are indeed in progress because one of the tests failed. So it should have 2 items deployed. I don't know. I think I commented something out here earlier when I was copying over the contract. So can't seem to see it right now, but should be deployed. Assert OK. And should be passing. I'm not sure why it's not passing. But the rest of my tests are passing. These contracts are definitely there somewhere. Oh, I expected 18 to equal 2. I think, oh yeah, it failed. Sorry, it failed after those should be deployed. Originally, I had only deployed 2 items with my contract, but now I'm actually deploying 18 because I've moved to deploying all the validator profiles for testing the UI. So my deploy script, which is over here, it actually deploys all 18 of these validator NFTs. So if I change that to be 18, I'm going to actually change my test, and then I'll retest. And you see how fast tests are when you just go back and forth and back and forth. So it's much better to do this now with your contract and with the way that you want to deploy your contract to the network, with the various sort of settings. Like I want to deploy 18 of these NFTs when I deploy my contract. So I might as well have a test that either passes or fails given that parameter, right? So you can browse through the rest of my tests here. So it should not accept the bid if the auction is closed. So when you first deploy the contracts, the auction starts out as closed. And I've made a comment here for myself just so I know, the auction is closed up to this point and then it's open after a certain point. It should allow the minter or the owner of the auction contract to open the auction. So it should allow the owner to open the auction, and the owner here is Alice. It's just I affectionately name these accounts here. Account 0 is always the deployer of the contract unless otherwise specified, and then Bob is sort of just like a normal user. So you can see what it would happen if Bob tried to open the auction. So we can run a test again for that. So, there could be another test here actually saying should not allow the person who doesn't own the auction contract to open the contract. And you'll see that it's actually caused a lot of errors, and that's because the auction is actually not open. So none of the other, this comment doesn't make sense anymore, and none of the other functionality of the auction is working now, the auction contract. Whoops. So let's put that back to Alice just so we don't forget, and we can look through the rest of the tests here. So open auction, it should allow somebody to name their address. So you can set your name. So when you donate or you're part of an auction, you can say, I want to be, so-and-so, or you can actually leave your address as anonymous. So it'll just say anonymous. I'll show you guys a running version of this later. But basically, the rest of the tests are sort of should accept a bid, should do this, should do that. And it's really, it's probably I missed some coverage here, like in terms of covering all cases. Like for example, I should have another like should not kind of like a function in a test, should not let Bob open the auction. So I should actually include this test. So I should just copy this functionality here up until this point, and then just say, Bob tries to open it, and we saw that that didn't work. But here, what I'm doing is I'm actually catching the error. I could print it out, but I'm just catching it so that it doesn't break the whole test run. And then what we want to check here is we want to make sure that the auction is actually not open. So we want to check. We're going to read the data is open, and then we're going to check to make sure that it's false. So we're going to check that the auction, that Bob could not set the auction. We're going to catch the error so that it doesn't crash the whole test. And then we're going to check to make sure that the auction is in fact still closed. So you can see here, should not let Bob open the auction has passed, and things look good. So that means that the assertion here was true, that is open equals false. So so that's it. Like, I don't want to go too in depth, but that's pretty much it for tests. And it's sort of like you're kind of, imagine writing tests for smart contracts as sort of like you're in a chess game with yourself. You're basically trying to write a test that describes what you want your contract to do. And then you have to go over to your contract and you have to write functionality to support that. This is the auction contract right here. So you have to write a function that would actually support that. Something like toggle is open was used here, right? So toggle is open. And then you have to come back and sort of try, as sort of like this chess game, you have to write tests that will try to break that functionality. So if I didn't have this modifier here, this is called a modifier. It's in Solidity. I don't have time to go into the whole Solidity language here, but you guys get the drift. There's some sort of gate, some sort of protection on this function, and it's only available to the minter. And the minter is like, it's either the minter or the owner of the contract. It's basically the person who deployed this contract or is the current owner or administrator. But anyway, that's why Alice can call this function, but Bob cannot. So if I were to remove this and redeploy, you would actually see the should not let Bob open the auction test fail, because Bob will have actually opened the auction, and the assertion here of the test, like should not let Bob open the auction, this will actually be true, like, or this will actually go through. So this transaction will happen, and the value of is open will actually be true and not false. So the assertion will fail, which means the test will fail, and everything should be sort of like in check. Okay, I know that was like a lot, but really it's just, we're just flicking a Boolean, so don't worry. Okay, let's go back to the slides a bit, and let's take a look at, I've written a couple of like sort of sample tests in here, which I've already talked about, which is like, some of these tests, you want to read data out of the contract, and you want to make sure that you have the correct data. Maybe it's from a deployment, like should have 2 items already deployed when the contract is deployed. Maybe it's just being able to return the name of some address, so you want to read the name for a particular address. So you can test by reading data out of the smart contract. And you also can write tests by actually changing the state. The state of the smart contract is basically the storage, like the actual data. So think of every smart contract as like a database, and you're changing items of that database. So here under testing transactions, I'm setting the name of Alice and Bob. Oh, I lost my screen share. Sorry, guys. Sometimes my Zoom crashes out here. I'll be back in a sec. I think we're back. Okay. So here we have testing transactions that actually modify the state. So for example, we can set the name of a particular Alice. Notice how if I don't fill in the from here, it's going to default to the 0 address in the truffle test, and that's the one that I'm actually using for Alice. If I fill it in, if I say it's from Bob, it's actually the Bob that I'm using up here. So it's these accounts. So I just don't want to confuse you guys, but basically I just do this as a shorthand. I just consider that there's 2 people and they're sort of doing stuff, and it's a little bit of a sort of like a just, I'm lazy and I don't want to type everything. So you're going to read the name, the action. You're going to get the name from the auction of the particular address. So in this case, it's Alice, the actual address variable. In this case, it's Bob, the address variable. And you're going to check to make sure that they equal Alice and Bob. So that is an example of we set the name, then we read the data, then we checked it. So we're making sure the transactions will have been completed and everyone's good. Now there's one last type of transaction, and that's one with value. So one where you're actually paying for stuff. So that would be one with 1 tokens, right? So in this case, you want to maybe be explicit. It's from Alice with a value price. So price could be, you can just hard code in some number. In this case, I have a variable called price, and that's just it's called a big number. It's a special JavaScript type. It does come from this Web3 utils, which is just part of the truffle contracting. So it's just a big integer. And the price, I think here is, I should have actually written it down. It's, I think this is also 1/10 of a 1. I don't know. You have to count the zeros to check, but I don't want to do that now. So it's 1/10 of a 1. I'm pretty sure, because I didn't want them to be too pricey, just in case we needed to run a lot of these bids. Okay, so let's move on. So we're going to switch gears. So we were just inside Truffle, and we were just writing our contract and going back and forth between our contract and Truffle test. And once you're successful there, you actually want to start to use the Harmony JavaScript SDK to actually talk to your contract from your dApp. So what you want to do is you actually, if you look here, you don't want to just be calling contract functions like setting the name of the user and reading that data out inside this truffle test, that doesn't do anything, right? So you actually want to do this inside an application. So you would present the transaction to the user would accept and say, yes, I want to do this transaction with your application using my account. And then it would go ahead and it would process, and then once it's confirmed, you can read the data back out and you can tell the user it was successful. You change the contract state, so you change the data of the underlying contract instance, and here's the result. And then everyone else on the network is going to see the same result. So what we need in order to make this successful is we need to connect to the contract. And at the bottom, you see I'm very explicit about the fact that really at the end of the day, all you need is a contract instance. So that is a JavaScript object that is describing your contract as it is live on the right network. So which network are you connected to? Is it local? Is it mainnet? Is it testnet? And then you need the right address of the contract, right? So, and you actually, you typically can't get the right instance without the right address. But it's these three sort of pieces that come together to give you that instance. And this is really the crucial point. And it's just one thing I've seen a lot of people like lose time over, because they think they're talking to the right smart contract, and they think that they should be seeing transactions change that contract's data, or like update the contract state, but they're actually talking to a live version of the contract on a different network. Or they're talking to an old address, but they're on the correct network. And you can see how this would like totally blow your mind. It's if every smart contract is a database, and you're connected to a database that looks and feels exactly like the database that you think you're on, but you're not on the right one, then you're gonna have a bad time. Like you're gonna be putting these transactions through and thinking to yourself that there's a problem in your smart contract. So then you're gonna start editing your smart contract, trying to redeploy, and it's just a nightmare. So always, always, always make sure that you're talking to the correct, you're using the correct contract instance, and that means that you're on the right network with the right address. So the other things that you need are the ones up top here. So you're going to need the SDK instance with the network config, like pointing to the right RPC. I'll tell you what that looks like in a bit. I'll show you that in the code. And you're going to need that contract artifact JSON. So that stuff I showed you, that big JSON file, you're going to need that as well. And you're also going to need to know which address your contract is. Again, you can be on the right network, but you can have the wrong smart contract address, and that's not fun. Okay, so there's a few helpers that I've built over the course of building these Harmony dApps using our JavaScript SDK. One of them helps you with the configs. So I mentioned last week that we have this .env file that has all of your environment variables for your different networks, and there's also a little file in almost all of the Harmony, the HRC repo examples, which are linked to in the last slide here. There's another file called config.js. Now this file, config.js, is really just like a loader for all of those environment variables, and they would expose them into your dApp so that you can use just regular sort of import syntax like this, and you can say, okay, get my config, and then out of the config you can pull out things like which environment am I on? So this environment variable might be local, might be mainnet, might be testnet. You can pull out the RPC URL that you're currently using. And this is all, by the way, this is the same information that Truffle used to deploy your contract. So this should keep you in sync. That's the point of this helper. Other sort of convenient methods or convenient sort of variables like gas price, gas limit, just some defaults that you can use. Harmony -utils now, this is a bit of a different one. This is really specific to getting that contract instance. So there's a convenience method that we can import here called get contract, which I'll show you in a moment. So again, and just some disclaimers here, some of this stuff is abstracted away for you, just like in the truffle testing. Like you don't really know how the contracts are being compiled or how the contract is being connected to. But if you do want to know, and you don't want to go crazy with if you encounter some sort of error or your environment doesn't perfectly match these examples and you have some issues, just remember that you should just follow the imports. So go dig into the actual files where these are coming from. It's abstracted for your convenience, but if you use it blindly and you just assume that it's always going to work, and you don't know what's going on under the hood, then it could cause some problems. So just in case you run into trouble there's just a warning. So let's, just before we get into the DApp side of things, let's talk about detecting an extension. So as we know, a lot of dApps use an extension. So they'll have, like in Ethereum, it's your MetaMask. And with Harmony, we have Math Wallet. So we can use Math Wallet as a Chrome extension to talk to our Harmony SDK and to basically open our account and ask us, hey, do you want to use this account on this dApp? And Math Wallet will pop up and it'll allow us to select. So what we're doing here is this is an example that's in all of the HRC client repo examples, repositories. So you guys can go check it out for yourself. It just lives in the Redux file. All of the client-side examples, whether it's fortunate or unfortunate, are written in React. So you just kind of have to navigate your way. If you're trying to write like a Vue.js app, you just have to navigate your way to the Redux folder, and you'll see that most of the code in the Redux folder can actually just be lifted. Like this entire function could be lifted up, and it could be just modified ever so slightly and dropped into your Vue.js app. But you would have to do the translation yourself. You wouldn't have to change much. But basically, we were gonna init the Harmony instance here. So we wanna have this Harmony JavaScript object that we can talk to either talk to the Harmony network directly, or we can talk through the extension. So down at the bottom, you'll see that it's just returning the Harmony that we created up here, talking to this URL. Or what we're going to do is we're going to wait. Excuse me. We're going to wait till we see the injected Harmony instance. So we're going to. This is a little helper convenience function, but we're going to wait to see if we have an extension. It's called injected, but really it's just the extension is exposing itself to this application. We're going to see if that exists. And then if it does, we're going to actually define the Harmony extension instance here. And we're going to connect to whatever network the Harmony extension says we're on. So you can see here that we don't actually pass in any URL or any RPC. In this we do, but down in here with the Harmony extension, we leave it up to the extension to decide which network it should be connecting us to. So we're actually going to connect to whatever smart contracts we're talking to, or whatever account we're talking to, through the whatever network the extension is on. Anyway, this is just an aside, so you don't have to fully get it right away, but you can check it out in the examples. And if you have Math Wallet, that's great, because it'll pick it up. So let's talk about reading data from a dApp or from a contract from within your dApp. So I mentioned there's a get contract helper method here. What it's expecting is you can put these in. Some of these are optional, but it's expecting you have either or a Harmony variable here or a Harmony extension variable. It doesn't matter if you leave one of these. If you leave Harmony extension blank, for example, it'll default to using this one. Oh, I lost it again. Give me one sec. We're so close. We're almost done. All right. I don't know why. I think my just gets overloaded. All right. Okay. So so you can leave out the Harmony extension, and if you're just testing locally, or you're just testing with let's say you're testing with a private key that you just hard coded in because you just want to talk directly through your DApp to your contract, and you don't want to use an extension, that's cool too if that's how you want to test it. And then you need to, the second parameter here is the contract artifact. So that's that big JSON blob that you need about the contract. Now, what this convenience method is doing is it's basically just going to give you back it's going to give you back the network. So it actually reduces this and this into just HMY. So whether you're talking directly to a Harmony network through your DApp, or whether you're talking to the Harmony network through the extension, it's going to collapse that into HMY. Then it's going to give you your contract, and the active here, that should actually, like, technically that should say account. It's basically just some object that defines like an account. So it really just has an address field. So don't worry about that. But you guys can kind of poke around and inspect this. But really, it's just a JavaScript object, and it has a field .address, which is how you'll talk to your contracts. It's shown down here. So this is, again, this slide is about reading data. So let's think about this. We will define some arguments for gas limited gas price just to make sure that we don't run into any errors with the JavaScript SDK. And these won't actually be used for these calls that we're doing. But you'll notice that every contract method, every contract has a list of methods. And under this this list of methods, we have the method, and this is for my auction contract. So just, you'll have to kind of bear with me here. This variable name is pretty arbitrary. It's just some method on my contract. But we're going to call it, and then it's a little bit of an odd syntax here. You actually have to call this, and then this whole piece becomes, it's sort of like a closure that exposes another set of methods, and one of them is .call, the actual arguments. So it's really weird, a little weird for the calls here, but basically this will go to the public variable is open, and it will call it, and then it will basically return the value here. The other way is that you might just be calling a method. So it could be it's a public view method, can be used with .call, and this has a parameter of address in it. So again, if you feed it the active accounts address, then you will get back the active name of that, like the name that the person set. So if there's no name that comes back, the person hasn't set a name yet. So that's reading data. Let's talk about contract transactions. So again, this is the same stuff we did in our truffle test. We read some data. We made some what people refer to as sort of stateful transactions. So we made a change to the contract's state. So we sort of updated some data. So in this example here, I'm just sort of kind of trying to abstract it here, like, for you guys. So it's the same thing, get the contract instance. Then we're going to set a transaction. And in this time, we're actually going to call the contract method, or sorry, I'm just abstracting this. I'm just saying, like, any contract method, doesn't matter. You put in your arguments here to the method, and then you would hit you would call .send. So instead of .call, you're actually sending the transaction now. So you're sending this to the blockchain. And who is the transaction from? It's from this address. So this address, if this is a method that requires some value, like some 1 tokens, this address needs to have this this many 1 tokens in order to call this. sorry, I'm mixing contract calls. Forget about that. Just assume that this is sort of some value for some argument. It's not actually, it doesn't have to do with one tokens. The value of one tokens you would actually write in here. I'll show you that in the next example. I'm just jumping ahead. So basically you would call a contract method. It could be any name as long as it's a name of a method in your contract. You put in the value of your arguments, call.send. From which address? Well, you need to specify who is actually doing the method sending here, like who's actually going to be calling the function. So it's these are just the sort of basic parameters, and then there's a few sort of progress methods here. These are listeners for when you get the transaction hash. So immediately the blockchain is going to return to you a transaction hash. But that doesn't mean that your actual change to the contract has actually gone through. It's only until you get a receipt and a confirmation, until you can be assured that your transaction actually went through. And the confirmation value here will actually say confirmed in all caps or rejected. So, and then if you had an error, that error would be in actually sending your contract. So again, it's a lot, but you guys have the recording of this video, and you also have those HRC examples. So just take a look at those, and if you want, just come back to something like this, and you can check it out in detail, and you'll see that these, in all the HRC examples, these are all logged out just for the sanity of you trying the example. Like you can actually see the transaction being processed as these steps happen. So let's go to the last one, and this is the one I was sort of alluding to. When you do a one transaction, whether it's a one transaction, you can actually specify the value field here. This is a one transaction from an account to another account. So you'll see all the fields I've highlighted here are specific to transferring ones amongst accounts. But if you notice the value field here, you can actually have a smart contract method that accepts a value argument here as well. You can see an example of that in the auction under the make bid function. In the make bid function, you actually have to specify a value, because you actually have to send, not only are you making a smart contract function like method call, but you're actually sending the one tokens to prove that you can actually make that bid amount. And the smart contract checks to make sure that the value you're sending matches up with the bid, like in the sense that you're gonna outbid the previous bid. So here, last example, this is the last one, is how do you make a transaction from an account to another account? So let's say you wanted to make a web-based wallet where you could send one tokens from one account to another account using the Harmony extension. So for example, we have Math Wallet as a Chrome extension, but you'll also notice if you go to the web wallet of Math Wallet, this is actually the code that would be running under the transfer part of that web wallet. So when you go to Math Wallet and you go click on web wallet, and you get taken to the page that allows you to send one tokens. I think Robin did a great video of that where he was sending one tokens back and forth. You actually, you're actually running this code here. So you're running the same code here. So it's a little bit different, but you'll see the same things: transaction hash, transaction receipt. These are the things that we're looking for to ensure that we've actually successfully transferred that amount of one tokens. Okay, so we made it to the end, and I tried to make it short, but I think I kind of ran over. But it's okay. I tried to get it down to like half an hour, but I hope that was useful. We've got some resources here. So this is like sort of the official Harmony HRC repo here, and then we have my fork is sort of like the latest one. So if you're following along in these tutorials and these videos, and you're not seeing the examples here, just check out my fork. I every now and then I move the stuff into the official repo, and I have to do. I'm a little behind on that right now, but I have to move that into the official HRC repo. But you can always jump into my fork to see what the latest is. And then Truffle, any information about Truffle and how it works is here. Any information about Solidity and writing contracts is here. And any information about the underlying Harmony network is here so that you guys can run your local nodes and do testing and stuff. Okay, that's it. Lee's muted, but I saw him clap.
Do it.
Thanks, Lee. You're my biggest fan.
Thank you.
All right.
Thank you, Matt.
Thanks, guys. Yeah, I hope it kind of illuminates a little bit of what's going on. I wanted to show you one last method here. If you look at the make bid, I kind of said I was going to show you this. This is a contract method. It's called make bid. Let's go look at it in the actual contract itself. So here's the actual function, make bid, right? And then if we look in the, and this is actually from the DApp. So you saw me demo this last week where we actually made a bid for one of the NFTs. So you'll see here that I'm actually calling make bid. I'm passing in some argument, right? Like an actual parameter, and this is the index of the item in the auction that I want to bid on. And so you'll see that gets passed here. And then the only confusing part would be what happens with the value, the amount that the person wants to bid. So the amount, it says, this is my own note to myself. I said, making bid for item index, and this is the amount that I'm willing to bid. So this could be a value like 0.1 or 5 1 tokens or whatever. And then here I'm just converting this. The reason why it says as Ether, we had a question about this last week, is because you need to convert an amount like 5 into something that has 18 decimal places, because Harmony 1 tokens have the exact same amount of decimal places as a single unit of Ether. So we're just converting that here, and it's just going to blow. So it would take a number like 5 and it would convert it to that. So that's what actually gets passed into the value here. And then inside the contract, we're going to check the value to make sure it's bigger than the previous amount. So you can see here, I actually check the total bids for that item. And then I get this value. It's just an integer, and it's called I just call it TBS, so total bids. And if the total bids is greater than 0, I'm going to get the last bid, and that's always the length of total bids minus 1 for the item. So I'm going to get the bid, and then what I'm going to do is I'm going to require that the message.value, this is a little Solidity crash course here, I'm going to require that the message.value is greater than the previous .amount. So the previous is what? The previous is the previous bid. So the last bid on this item. And then the message.value is what? Well, it's the value that the person wants to bid for this item. Now, if they are lower, this transaction will actually fail here. It will revert and it won't do anything more. And it will actually, it will cost the sender the gas fees, but it will not cost the sender the value that they sent. So you could send a bid for, let's say, 101 tokens. If it is not greater than the previous amount, you will get your 101 tokens back, but you will not get the gas fees back. So you will basically fail to outbid the person, but you won't lose your 1 tokens, of course. So that's about it. I'll just go through the rest of it because it's only like 3 more lines. But if it's successful, so if you pass this point that your let's say JB bid he bid 100 on an item and I bid 101 tokens. What it's going to do is it's actually going to return JB's 101 tokens. And there's an example of that in the video from last week. It's going to return JB's 101 tokens by creating a variable here, an address that is payable of the previous owner. So that's the previous bid's owner. And it's actually going to transfer the value from this, the value of JB's bid is actually locked inside the smart contract, and it's going to transfer that value out of this smart contract to the previous owner. So you can see that it's transferring the previous dot amount. So JB is going to get his, if I outbid JB, he's going to get his 101 tokens back, and I'm going to be the next previous bid if somebody tries to outbid me, because I'm going to be the bid at the total bid's length minus 1. So that's kind of how it works. And then what it does is, if it's successful, it will push my bid onto an array of bids. So this becomes like a history of all the bids. That's it basically. So I hope that kind of makes sense. And I hope you guys have been sort of like seeing this sort of auction example take shape. There's still a few more sort of UX, UI UX issues that I want to do. And I've been working this week on actually deploying it. So you saw all these URLs for the validator logos. I've actually hosted them now. So the Harmony is going to host those validator profile images, and I'm looking into sort of how we're going to do the hosting for the dApp as well. And then soon we'll all be able to go to this dApp, go to the dApp on mainnet with our 1 tokens, just small amounts, just for fun. And we're going to be able to kind of bid on this dApp. So it's going to be really fun. All right. So that's about it. I think that covers it. I think we got time. I can hang out. Anybody got any questions? You guys all working on Pangea, crashing the network, P3. Everybody's busy. All right, so JB, you got a question? Or
no, I've got no question, but we're not busy now, huh? We're listening to you. This is our time off.
Awesome.
Easy time. So thank you very much.
Yeah, you're welcome. So now we have 2 videos that have covered a lot of the topics of deploying the contracts and sort of dealing with the various sort of setup, the network, the JavaScript SDK, but also just I would highly recommend that everybody just test rigorously before you jump to writing your dApp, because when you have to change your contract and redeploy and do all this stuff, it's I'll put it in terms that like POps would understand. It's like deploying the node again, or restarting the network. So, you know, redeploying your smart contract is kind of like restarting the network. You wipe out all the data, you have to start from scratch. It's really annoying. So make sure that you test iteratively really fast in this tight loop of just using truffle tests and stuff to make sure that like you can't avoid redeploying contracts sometimes, but you want to make sure that your contract is like covering all cases. So I think that's it for today. Lee, you've got the recording, so yeah, DM me later, and we can stop recording now.
Yeah, we'll upload
but send it to me later, and we will put it up, and I'll link it up in the slides, and we'll put it all together.
Yep, we'll do that.
All right.
Cool. Thanks again, Matt.
Thanks, guys. Thanks for joining.
Yeah.